Welcome to Mastering Node.js video course by Pact Publishing. Hi, my name is Joris Hermans. I'm a senior software developer who loves to write open source software. I'm one of the first users of the isomorphic JavaScript principles, sharing your code between the client and the server. I created also the course about ECMAScript 6 moving to the new JavaScript in the past to teach viewers all about the new specifications of JavaScript. For the moment, I'm very excited about the distributed web. Node.js is a very powerful technology to write full-stack software in one language. With this course, you will understand the Node.js platform even better. We will touch a lot of the Node.js APIs and look even under the hood to show you the full potentials of Node.js throughout the course. This video is just a glimpse to know what the course will bring to you. This course will make you a total craftsman in Node.js. A course about technology can't be better started than explain to you how Node.js is working under the hood. We'll create an application that will show you how Node.js is working and what the basic principles of Node are. We'll do that with a sample application v8_shell. In this v8 shell example, we will create a new method alert. In this method alert, we will return alert arrow high. We will also learn a lot about the event loop, and that bring you into the loop of how this even works. After that, you will learn how to create tools like Yeoman, command line interface tools that will help you in automating tasks from within your console and to interact with your end user. In this section we will work on the following program. Node.js is an event-driven programming environment, so it's important to dive into the Events API of Node.js. You will see everything about events in section 3. Another important part to master is streams, when you can transform data from one format to another. This is very important today with big data. In this course we will show you how this functionality works with some simple examples. This will bring you at the end of this section to the basic functionality of an HTTP server in Node. Now how to write this. We can start here, node server, then we have our server that's been running, and this server serves a static image node.js. In section 5 you will learn how to use Express.js, the most popular web framework in Node.js. We will show you how to work with middleware in Express. Also, authentication and security is an important topic when building a web application. But it's so much more fun to show you how to implement a social login for the biggest platform in the world, Facebook. At the end of section 5, we'll show you Koa.js. Koa.js is another web framework from the same creators of Express.js. In section 6, you'll learn how to work with the file system API of Node. With some simple examples, you will become known of the key principles of that API. We can, for example, watch the changes of a file. When we type in this file beep, we can generate a beep in our console. That's great. That's something awesome that we will see in section 6. Another very important topic to become a master of Node is this section, section 7. In this section you will learn to control the Node.js process. You will learn how to control multiple processes and send messages from one process to another. So we will spawn multiple Node processes with Node and then the JavaScript file. And then we can send messages through the other process. Another very cool topic to master is real-time messaging systems or real-time applications. We will do that with Express and Socket.io, and we will learn also how to cooperate with server-sent events and how to send messages from one server to another. We'll have no secret for you after this course. We will create in this section a document editing tool. This is our document editing tool that we will build, so we can add a lot of items. And in section 9, we will see how to scale our application, and we will bring our document editing application into the cloud with Docker. So we will spawn our real-time application together with Redis into a Docker container. We will prepare it to send it to the cloud. In the last section, we will have one important step for you to make you sleep very well. When you write software code, it's important that you can look after the quality of the code. So using the correct tools for this job is also very important. So we will give you some kind of example how to spy on our bond object. After this course, you will be able to master Node.js and all of its APIs. It would be a good thing that you have worked with Node.js before, but that's not necessary. Some background in programming languages like Java or C# are a plus. This course will help you in creating great Node.js applications and bring your skills to the next awesome level. So let's begin this journey together. Hi and welcome to the installation and setup video. In this video, we will explain you the prerequisite software that you need to follow in this course. In this video, we will give you some instructions about Node.js. We will cover how to manage multiple versions of Node.js, and at the end, we will give you some information about NPM. Node.js is a JavaScript runtime built on Chrome's V8 JavaScript engine. Node.js uses an event-driven non-blocking input-output model that is lightweight and efficient. It's created by Roald Dahl of Yoent, the company that started the Node.js project. Node.js exists in two versions, the LTS, short for long-term support version, and the latest version. This is the LTS plan. Take a good look at it. Every major version covered by the LTS plan will be actively maintained for a period of 18 months from the date it enters LTS coverage. It's something important to take into account when creating Node.js packages. Now let's install Node.js. For that we will use NVM, short for Node Version Manager. It's a tool to manage multiple Node.js versions. To install NVM, we need to execute a curl command. To verify that NVM is successfully installed, we can execute the following bash command. Now let's install Node. That is what we were planning to do, right? The -LTS option installs the long-term support version of Node. I see you thinking, how can I install a specific version? Well, you can do that as follows. By typing nvm install for when you want to verify the kind of Node.js version you are using, you can type in node-version. This will print the version that you are using at the moment. In this course, we will work with the latest version of Node.js when the course was recorded. NPM stands for Node Package Manager. On Node.js, you will find a lot of packages created by Node.js programmers and companies. When we go back to our console, you can verify if npm is installed well by typing npm-version. As an IDE, we will use Visual Studio Code, the editor developed by Microsoft on top of Electron.js. It comes with useful plugins on top of the IDE that can help you execute tasks and provide you with snippets. Visual Studio Code allows us also to use our editor together with an integrated console. It's much easier to show you some code and then execute commands in the console. In this course, we saw how to install and prepare your computer with the necessary software so you can follow this course very easily. Now we can go to the next volume of this course. Hi, and welcome to section 1 about understanding the Node.js environment. In this section, we will look at the architecture of Node.js and what are the internal components that Node.js is constructed of. We will use the read eval print loop of Node. In the last video of this section, we will look at the event loop. Now we move on to the first video of this section that deals with Node.js under the hood. In this section, we will dive into the architecture of Node.js and take a look behind the engine. It's important to understand how Node.js is built. This will help you create a greater application in Node. In this video, we're going to take a look at the overall architecture. Then you will learn the low-level components that Node.js consists of. We will take a closer look at V8 and create our own instruction in a sample application that uses V8. Node.js is in a certain way an extension of JavaScript. A lot of programmers know how to work with this language. It's the only language natively available in the browser. This made Ryan, the creator of Node.js, think back in the days. Why not use one of the JavaScript engines and extend it with powerful APIs so that we can use it in the server? Computer program is a couple of computer commands that a low-level hardware unit can understand. That is why there is assembly. However, writing your program is not that very efficient and very practical. That is why you will find layers on top of it. In many cases, it's a C++ layer. Node.js also has a C++ layer. V8, the JavaScript engine, that is also used in the Chrome browser, sits in the C++ layer. Also, the libuv library is a C++ component. libuv is a component of Node.js that is responsible for the asynchronous I/O, input-output. In the beginning, it was only used by Node.js. Now some other software projects are also using libuv as a component in their architecture. One of these projects is Julia, a programming language for the data scientist. If you want to know more about libuv, you can always go to the GitHub repo of libuv. Of course, you need to be familiar with C++. Another important component is a V8 JavaScript engine. This engine interprets the JavaScript. It's also the bridge between JavaScript and the C++ code of Node.js. With V8 we can expose certain functionalities of C++ to JavaScript. Let me explain to you how this is done. This will help you to understand Node.js a little bit better. In the samples of V8 we have a shell application. So we open this. This application extends V8 with a new functionality. In the method createShellContext, we bind the print, read, loop, quit, and version functionality to a C++ function. Print to the print method, read to the read method, load to the load method. Now we can execute this shell program that interacts with V8 in our terminal. We do that as follows. First of all, we need to go to our out folder, and then we need to choose x64.release folder. Then we can just type in v8 underscore shell. And now we are in our program. Now we can type in version. We can quit our program. Let's build a new function binding to V8 called alert. It will print our string with alert before it. Now we need to bind this C++ method to V8 in the createShellContext method. So we can copy paste this line of code. Then we can change here version to alert. And we can here change version to the alert method. This refers to this method. So whenever a user types alert in the shell, he will execute alert, the C++ method. We also need to add alert here. So we copy paste void version. And we change this to alert. Now I compiled our C++ code into binary code again. Now we can execute this program by typing v8 underscore shell, and then we can type in our alert function. This results in the following result. We can also do this. It results in 3 because it's just JavaScript that's been interpreted, and our alert has been going through to our C++ method. Don't mind if you are not familiar with C++. This is just to let you know that Node.js is executing C++ code under the hood. For example, the require method to add new references to Node.js modules uses a C++ implementation to make this happen. It's very important to know that under the hood of Node.js there is a C++ implementation. And there is also a possibility to extend the Node.js APIs with your own C++ code, of course. It's completely up to you what to do with that. In this video, you learned everything about how Node.js is built and what is its architecture. In the next video, you will learn everything about read, eval, print loop. See you there. Welcome to the video about read eval print loop. In the previous video we looked at the architecture of Node.js. In this video we're going to take a look at read eval print loop. We will look at what is read eval print loop and we will use it in Node. REPL stands for read eval print loop. REPL is an interactive way to go and test a platform without writing a whole computer program. It allows you to type in certain commands that Node understands and can react upon. Read takes the user input. It parses the input and stores the JavaScript output in memory. Eval means it evaluates the command that the user entered. Print means it prints the result. Loop means it loops the above command until you press Ctrl+C twice. When you are experimenting in Node and you want to debug JavaScript code, the REPL feature of Node is very powerful. The REPL environment of Node.js can easily be started by entering Node without any parameters in your console. Here we go. Now try some simple mathematic expressions, such as 1 plus 1. Well, the REPL answers 3. We can define some variables, for example x equals 1. We can also define some variables with var y equals 2. He prints out undefined. This doesn't matter. It's not that there is some kind of error. It's just normal, because he reacts upon var y equals 2, and this is just something that's been undefined, but when we type here y, you will see that y is equals to. Now we can type in x plus y. This results in 3. The REPL tool of Node also supports multi-line expressions. 4. Then we will print out something in our console. And then we will stop our multi-line. That's great, right? Okay, now let's type another multi-line. And then you think, what? I made some kind of mistake. How can we go out of this multi-line expression? Well, we can do that with .clear. Another special feature of the REPL is the use of the underscore. With the underscore you can recuperate the result of the previous expression. So 1 plus 5, 6. Then we can type in var sum equals underscore, and then we can say sum, and sum is 6 because it's the result of the previous expression. So we put 6, the result of the previous expression, into sum. With the up and down arrow keys we can navigate to the history of commands. With .save we can save our current session to a file. Now we saved it to REPL session. With the .load we can start from a previous REPL session. With .help we get an overview of all the commands that we can use in Node REPL. Sometimes you get stuck, this gets you out, it's the .break. .clear is just an alias for the .break. We can enter editor mode with .editor. We can exit the REPL with .exit. We can print out help, and then the load and the save actions we saw before. Now let's quit our REPL environment with .exit and move on. Great to have you listening so far. In this video you learned what read eval print loop is and how we can use it in Node. In the next video we will look at the event loop. Hi and welcome to the third video of this section about the event loop. In the previous video we looked at Node REPL. In this video we're going to take a look at some history about the event loop. We will look at some JavaScript code in the browser that explains the event loop and some code in Node. Back in the days, Ryan, the founder of Node.js, found out that most high-performance servers followed a similar concept. The architecture are similar to the extent of an event loop, and they work with non-blocking input-output operations. This has an advantage that when an incentive operation doesn't block your entire application. And it's a good approach for applications that need to handle thousands of simultaneous requests. Most of the servers use a multi-threaded system. They process every request in another thread. Ryan decided to try another approach, a single-threaded one. So all the requests that come to the server are processed by a single thread. The power of Node comes with the event loop, which works fast. The event loop is an application flow control that is terminated by events or changes in the state. You have a central mechanism that listens for events and calls a callback once an event has been detected or a state has changed. Node.js is offloading non-blocking I/O operations to the system kernel, which is most of the time multi-threaded. Node.js will be formed when these operations are done by a trigger of the system kernel. Now first of all, let us take a look at the following Node.js code. We have a request function here. And that's been executed by passing an anonymous function as a callback. Here a callback function. And when a response is available sometime in the future, this callback function will be executed and we will log status code and content type of the headers. So you will see that DOM is outputted immediately to the console. So when we execute this in our terminal, we get the following result. Indeed, DOM has been executed first, and then after that we see a status code and we see our content type. If you take a look at this code example, you will recognize some familiar code that you can execute in your browser. It reacts on a mouse click, and in this example a message is enqueued when the user clicks on the click L element and the onClick event fires. We add an event listener here with a click. So when a user clicks on it, he will execute this code. So when the message is dequeued, it's the callback function changeColor that is called. Event loop will continue when changeColor returns. Now we click here on, and you see that it becomes red. In a loop, the system polls for the next message, the next event, and will execute this accordingly. When nothing happens, no response comes back, or no button is clicked, the loop goes to the next event, and so on. When we have asynchronous code, such as set timeout, the provided callback will be executed on some future tick of the event loop. Because of the non-blocking nature of the system, the callback will be fired at 0 milliseconds in the future. In this section we give you some more background about how Node.js works so you can use it better. We looked at the architecture of Node, and we used the REPL of Node.js, and we looked at the event loop of Node.js. In the next section we will start to create our sample application and dive into the CLI development. Hi, and welcome to section 2 of CLI application development. In this section we will create command line interface tool. We will look at what a command line interface is and why it's important that you learn how to work with it. First we will implement an application without a framework, and then we will dive into the commander.js to develop our Node.js tool. In the last video we will add some extra functionality and bring our tool global with npm. Now we move on to the first video of this section that deals with CLI interactions. In this video, we will create a new Node.js application and intercepting arguments. We will also ask our user some questions and react to his input. Tools such as Yeoman, which generate projects, and Bootstrap code are command line interface tools. It's extremely important to learn how to create your own tools. As developers, we are lazy, and if we can create our own tools, it will make our life easier. In some couple of videos, we will work on a bot that we will interact with. This bot can do a lot of tasks for us, but first, let's create a Node.js application with npm init. This will initialize our application. We will now create an index.js file to start from. With the process object, we can access the arguments that are being provided when invoking node index.js. So we can type in process.rv. That's an array, so we can do for each on it. And then we have a function we can print out all the arguments. The process object in Node.js is a global object that provides information about and controls the current Node.js process. Later in this course, more about this object that we will cover. For now, we can just execute this program and see what happens. He prints out all the things that we typed in into our console. First two arguments we are not interested in, so we can slice this with the dot slice method of array. So here we slice and we remove the first two arguments from our object. Now we can extend this code to get some more interaction with our end user. Then we can react upon the value. Let's try this out in our console. So node index none hey. Cool. Now we are going to react upon input. We need to require the util library of Node. If we now want to ask some input from the user, we need to use the process object again. So when we type in input, we will react to the user input. With the std_in from the process object, we can listen to a readable stream from our console. std_in stands for standard input. We have a lot of libraries in Node.js that will simplify our code. In the next video we will use them. Now let's take a look at the result. In this video, you learned how to create a command line interface application in Node.js. In the next video, we will use libraries such as commander.js to make our life easier. Welcome to video 2, commander.js and prompt. In the previous video, we looked at how to write a command line interface application in Node.js. In this video, we're going to take a look at how we can use some libraries to make our life easier when creating command line interface applications. First of all, we will rewrite our application with commander.js, and for the interaction with our end user, we will use the library prompt. First of all, let's install our tool commander.js to our project. Now we can import the library to our project. We do that by typing program equals require commander. After that, we can set our version of our program and add some options. For example, an info option that tells a little bit more background about our application. With the -u or -upper option, we will transform all the output to uppercase. It's important to add a clear description. Commander generates a help output for you out of the box. That's great, right? Let's start creating our first command. We will start with the hi command. And in the action method of our command, we will respond with a sentence from Angelica that answers our greeting. Let's go to our console and type node index.js followed by our newly created command. Yes, our program answers us with our sentence from our console.log. Let's take our option of uppercase into account. Commander adds the options as a field property to our program object. So we can access it by program.upper. Now let's take a look at the result in the console. Nice, it's working. Great job. Let's build a more complex command, a command that will start our input flow. The input can be followed by a save variable that we can use in our action method. We can also add specific options to our command, such as in this example, the question option. We can just execute our new command without any arguments. This results in the following output. Now let's add our upper flag as an argument. When we add a name after input, you will see that it results in cannot save or lost flow. Now we need to add some prompt interaction to our program. We can do that like in our previous video, but this is too much code. In Node, you have a library called prompt. Let's install this. We also need to require this library prompt on top of our script. We type here var prompt and require prompt. Now we add prompt.start to our input command, and then we ask for an answer. When the user answers no, we need to ask him what the right question would be to get the answer. Now let's create another prompt.get to ask for this question to our end user. When we go to our console, we can look at our interaction flow.
These are the flows that we have implemented.
That is great. We're now able to set up complete interaction flow with our end user. In this video, you have learned how to work with Commander and Prompt, and how these libraries help us to write our command line interface applications. In the next video, we will look at how to take our tool globally. Hi, and welcome to the video about making your tool global. In the previous video, we looked at high-level libraries to create command line interface applications. In this video, we're going to take a look at when we need to choose for a global dependency instead of a local dependency. We will use the npm link, and then we will use our tool globally. At the end, we will look at another CLI functionality that we can use for a better CLI program. With the -g option parameter in an npm install command, we can install a Node.js library. But how can we install our program globally without pushing our library to npm? That is what we will show you in this video. When are we going to install something globally? If you install something that you want to use in your program, then install it locally at the root of your project. If you're installing something that you want to use in your shell, install it globally, so that its binaries end up in your path environment variable, like every global CLI program. Before we can install this package globally, we need to add the pref global property and the bin property to our package.json. So we type bin, and then we have in that bin angelic, semicolon, index.js. So when somebody types in angelic, he will execute node index.js. Add the shebang line on top of your script and the following line to say how your script should be executed, in this case through Node. When that's done, we now run the npm link to install our package and link it to the global directory of npm on your machine. Now we can go to whatever path we want and execute angelic input. Now we see that our application is accessible from everywhere in our console. That's just great, right? With the package colors, we can add some colors to our CLI program. It's always nice and fun to add some way to create some accents in your output to the console. We will add some basic colors to our application. First of all, we need to install colors in our project. We will do that by typing in npm install colors --save. Then we can add the colors.green method around the sentence to make it green. When you execute your program from another path, you will see that the sentence is printed in green in our console. That's great, right? It will always take our latest code changes, and this is because of the linking of npm link. In this section we created a command line interface program. You learned how to implement an interaction with our end user and how we can install this program so we can use it from anywhere in the console. In the next section we will dive into asynchronous events-driven programming with Node.js. Hi and welcome to section 3 about asynchronous events-driven programming. In this section you will learn how we can work with events in Node.js. First of all, we will see what events are, and then we will look into the details of a timer. We will have a video about creating our own event, and in the last video of this section we will cover the more advanced features of events. Now we move on to the first video of this section that deals with understanding events. It's very important to understand what events are and how to deal with them. All the functionality in Node.js is built around events. First of all, let's refresh the part about the event loop a bit. Event-driven programming is an application flow control that is determined by events and are changes in state. The general idea about events is to have a central mechanism that listens for events and calls a callback function once an event has been detected. Are you familiar with front-end development? Well, think of all the on functions such as element.onClick that are used to have user interactions. Node is using this in the form of event emitter. Node.js has a great documentation site. We will take a look at it for the event emitter information. On this site you will find a lot of information about the event emitter, how to use it, and what its functions and properties are. For us it's very important to remember the .on method and the .emit method. The .emit method fires an event, and with the .on we can hook upon that event. So when we click here on emitter.emit, go to the information about this functionality in Node.js. In commander.js we have two events where we can hook on. One for the help and one for the error handling. This is one for the help handling, so we can extend the help functionality of a program. We can execute this by the following command: node index -- help. Then here we see our extension examples events. Events is a program to show the viewer how CLI programs and events work in Node. Commander has also an event for error handling. You can use this as follows. When an error occurs, we can just create our own logging for the end user like this, and at the end we just exit our program with process.exit. Now let me show you how we can create and fire an event. First of all, we create a new command fire. And in this fire command we access the object process. The process is also an event emitter, So we can call emit, then the name of our event, gunfire, and then our message. Later on in our program, we can listen to this event with process.on, gunfire, then we have a callback with our message, and then we can print out something to the console. Now we can execute this in our console by typing node index fire something, and you will see that it will execute fire and emit it, and then in our on function we log gunfire. That's great, right? In this video you learned what events are and how they are available in Node.js libraries such as commander.js. In the next video we will look into timers. Welcome to the second video of this section about timers. In this video we're going to take a look at timers and why they are important in the event loop. First of all, we will look into the event loop operations order, and then we will look into how timers are implemented in Node.js. And at the end of the video we will use a timer in our sample application. When Node.js starts, it executes the script first, which may start asynchronous API calls, starting a timer and reading a file, and then it starts processing the event loop. The event loop has an order of operations. Each point that we see here is a phase. Every phase has a callback queue as a FIFO. First in, first out. When the event loop enters a given phase, it will execute all the callbacks in the queue until the maximum items in the queue are executed or the queue is empty. So let me explain to you all the phases. The first phase, timer. This phase executes callbacks scheduled by setTimeout and setInterval. The next phase is the input-output callbacks. This phase executes all callbacks with the exception of close callbacks, callbacks of timers, and setImmediate. Then we have idle prepare. This is a phase only used internally in Node.js. Then we have poll. This phase retrieves new input-output events. Node will block here when appropriate. Then we have the check phase. The setImmediate callbacks are invoked here. Then we have the close callbacks. These are callbacks that are closing, for example, a connection. Between each run of the event loop, Node.js checks if it is waiting for any asynchronous input-output or timers and shuts down cleanly if there are not any. In Node.js we have setTimeout and setInterval. These are familiar functions when you are a web developer. These functions also exist in the browser. So let's implement a timer that the user will inform how much time he has left to finish his input. First of all, we start with creating a new program. In our case, React. React as quick as possible. In this program, we code an interval, and every time this is executed, we tell the user how much time he has left. So first of all, we create a new variable for total seconds, 5 seconds. And then we set an interval You have here a function. And our interval longs for 1000 milliseconds. And then we tell the user how much time he still has left. Next thing that we need to do is schedule a timeout that will be executed once when the user has no time left. So we start with set timeout. Then we have also a function. And then we have 1000 milliseconds multiplied by our total seconds. We will also stop our prompt. We also need to ask the user to react. We can do that with prompt and then ask for an answer. When we execute this program, you will see that something strange will happen. So when we execute this, you will see that something strange will happen. Indeed, our timer keeps going. We can easily solve this by adding here a variable for show time. And then when we come to our timeout function, we can clear our interval. Also, when a user answers something, we can clear our interval. Now we can execute our code again, and you will see that at the end he will stop. Great. In this video you learned what the event loop operation order is and how to use timers. In the next video we will create our own event. Hi and welcome to video 3 about creating an event. In the previous video we looked at the event loop operations order and timers. In this video we're going to take a look at creating an event. We will first of all create an object and class definition, and then we will extend from our event emitter. At the end we will emit events to the end user who uses our object. In this video we will show you how to create a class with the possibility to send events and to receive events. To do that, we need to create a new JavaScript file. So we'll create a new JavaScript file with the name animal.guess.js. And then here we will create animal guess equals function. an animal gas will have a method start. And then we will print out something to the console. Then we can use our code in index.js. So we copy paste this code. Here we go. Of course we need to define here prompt, because we are using prompt here. Now we can use the animal gas class in our index.js file. So at the top of our index.js file, we can import animal gas. And now we can use here animal gas.start. Now we need to extend from event emitter. In Node.js we can do this by using the util library. So then we can create an object event emitter where we require events from event emitter. And then with util.inherits animal gas, and then the event emitter where we want to inherit from. So util.inherits is in Node.js a way to extend from another implementation if you don't use the ECMAScript 6 way. That's great, right? Now we have the functionality of event emitter in our animal gas class. Now we also need to export our animal gas functionality. So with module.exports, so now we can emit an event. We can do that with first create a variable var self equals this, and then we can remove console log, and we do here self.emit time, and then as an argument we provide the total seconds left. we can also emit when we end or timeout. Or when the user is given an answer. Now let's add a listener to our index.js file. So here we can add animal guess.on time. And then we have a callback with our total seconds. And then here we can print something out in the console. We also can add our end event. Now we can test this out in a console by typing node index react. You can just type something. So you can also do nothing. We came to an end. Was being fired here twice. Why? Because we came into the timeout, and we also answered something. In this video you learned how to create an event with event emitter. In the next video we will dive into the events in depth. Hi and welcome to the fourth video, Events in Depth. In the previous video we created our own event. In this video we're going to take a look at how to listen to an event once. We will look how to manage listeners, and we will see how we can manage our event names. Sometimes it happens that you're interested in the event only the first time. Then you can use the once function of event emitter to listen to an event only once. So we have here a time, and in the index.js we can use animal guess.once on our time event, and then we can print out something to our console. When we execute this in our console, we get the following result. That's great, right? Another part of the Events API is the listeners. You can manage them by telling the API how many other parties may listen to an event. Set max listener is a method to do so. The default setting of max listeners is set to 10. So here we can set our max listeners to 5, for example. Now, only 5 listeners can listen to events of animal guess. Note that the limit is not a hard one. It will allow more listeners to be registered, but it will output a trace warning to stdr, indicating that a possible event emitter memory leak has been detected. The event emitter has also a method to remove a listener. It's called indeed remove listener. We can use it like this. First of all, we need to define an option. We add a new option to tell our program that we need to remove our listener the first time that our timer ran off. Then we create a variable that holds our function. We call our variable endFn, and we provide it here. Then in our once method, we can check if we have an option. And when no end is there, we can remove just the function from animal gas. Now we can test this out in the console by typing node index react n. And our end function is not being called. If we do it without, we see our end function. With the event names method, you can ask what the event names are that your program is listening to. So we can print a console log at the beginning of our program. And we can add something at the end. Let's test this out in the console. The beginning is not listening to anything, and then you are listening to time and to the end event. In this section you learned how to use event emitter and what the event loop operations order is. We looked into timers. We also created an event and emitted it into the world. At the end we looked into some special cases related to events. In the next section we will look into streams with the section Streaming Data Across Nodes and Clients. Hi and welcome to section 4, Streaming Data Across Nodes and Clients. In this section we will see how we can use streams to handle data. In this section we will explore what streams are. We will look at some streaming examples, and we will create an HTTP server with streams, and we will handle post data on our HTTP server. Now we move on to the first video of this section, exploring streams. In this video you will learn the basics of streams. In this video we are going to take a look at what streams are. We will look at the 4 streaming types and we will show you the basics of streams and how to write some lines of code about transformations. Stream is an interface to work with streaming data in Node.js. It takes in an input and then it can be transformed to another output. All streams are instances of event emitter. Do you remember event emitter from the previous section? In Node.js we have 4 types of streams. Readable is a stream from which data can be read. Writable is a stream from which data can be written. Duplex are streams that are both readable and writable. Transform is a duplex stream that can modify the data. Because of its duplex character, it's indeed readable and writable. By default, all streams in Node.js are operating on strings and buffer objects. But it's also possible to work with other types of JavaScript values. Let's create a new command here. We call this command streams. Let me show you a basic form of streams. We can pipe the user input to the output of the console. So process.stdin.pipe process.stdout. Now we can test this out, typing node index and then the name of our command streams. We'll see that it repeats itself. It just pipes our input into an output. It's very stupid, right? Well, we can make cooler stuff with streams when we install true2. True2 is a library to write transformation code for our data. So at the top we place a reference to the true library and type in var true equals require true2. Now we can create a function that transforms our data into uppercase. We do that with var tr. Then we use true. And we have a function here with buff, our buffer, and with next to go to the next function in our stream. Before we pass our stdin to our stdout, we need to go through the true function. We can do that by putting here a pipe function. So first we have our stdin, we pipe it through our function to put it into uppercase, and then we give it to stdout. Now we can test this out in the console by typing node index streams . Great. Our program works. We can transform lowercase sentences into uppercase sentences. That's great, right? In this video we saw what streaming data is and how we can use this in our CLI program. In the next video we will look at streaming some object data with object streams. Welcome to video 2 about object streams. In the previous video we looked at what streams are and how to use them. In this video we're going to take a look how to use objects in streams. We will do this by looking into object mode. We will transform a stream into an array and use the library split tool. We'll also look into the data event of a stream and how to use that. Streams are by default string-based. You can work with object streams by explicitly telling the Streams API that you're going to work with objects. This can be useful when you're parsing a protocol, when you're parsing large files with meaningful full data into it. So let's create another command. Object stream. Within this command we are going to parse the input of the user and transform all of the words in the sentence into an array. First we're going to use the split2 library. It's based on true2 and will split our input into separate lines. Now we need to put a require on top of our index.js file. So start by typing split require and then the name of our library. First of all, we create a stream that parses our incoming data and split the words up into an array. So we start by creating a stream, then we use the true library with function chunk, inc, and next. So the first argument is our data, second is our encoding, and the last is to go to the next part of the stream. Then we can use the following code. But this will not work, right? Well, we need to add an extra parameter. We need to say to true that we are in object mode. Then we listen to the data event. So every time an object is being created, the .on function is being called. Remember that streams are event emitters. So we can here type stream.on, then data, the name of our event. Then we have a function with data. And then we just display our data to the console. This data event is being fired whenever the stream is relinquishing the ownership of a chunk of data. When the end event is fired, there is no data that the stream can consume. We also have the close event that's been fired totally at the end, and also the error event when an error has occurred during the event. Processing the data. Now the only thing we need to do is piping everything together. So we start with using process.stdin. We pipe this through split. Then at the end we pipe it through our stream object. Now we can test this out in the console by typing node index object stream . And this is the result. In this video you learned how to work with streams that are processing objects instead of buffered strings. In the next video we will cover how to create an HTTP server. Welcome to video 3, creating an HTTP server. In the previous video we looked at how to create an object stream. In this video we are going to take a look at how an HTTP server works and how we can use streams to manipulate data and send a response back to our end user. Node.js is a great choice when you want to create your own web server. It's lightweight and it can handle a lot of simultaneous requests. So first of all we're going to create a server.js file. And then at the top of this server.js file we are going to import the HTTP library of Node.js. The next thing that we are going to do is declare a variable server, and then we are going to create our web server with HTTP, and HTTP has a create server method. And that method has a callback with a request object and a response object. It's as simple as that. Notice that we use the arrow notation of ECMAScript 6 here. Now we can just send something to our end user by response.end. It works. Part hit. We also need to listen to a port. We use 8080. So we're going to define port and then we need to listen to it. Server.list or port and then a callback. And then the port. Great. And that's it. We have built our first web server. That's easy, right? Not a lot of code. Now we can run our server with node server. And when we now go to localhost 8080, we found it works. Path hit slash. If you now enter here another path, some other thing, then we get here some other thing. Just to name a thing. Now we can read a file for our end user. So file text. Here we put some random text. Now we can extend our code to read that file and stream it to our end users. So first of all, we need to import FS, or the File System API of Node. Then in our create server method, we read from file.txt and pipe the outcome to the response. So we start with fs.create read stream file.txt to read the file, and then we pipe that to our response. Now we can do cool things with the content of file.txt. So for example, we can bring it to uppercase. Sounds familiar, right? So we import true here at the top of our file. And then we can use the same method as we saw before. To bring it to uppercase. Here we go. And then we need to pipe it. That should do the trick. Now we can restart our server again in the console. Node server. We now refresh our browser. We see that we have in this file, we can write what we want, but will it work? Great. Now imagine that we want to serve this beautiful logo to our end user. Well, that's quite easy, I think. The only thing that we need to do is remove this. And we remove this. Then here we change it to Node.js logo.png. Now we need to start our server. And when we refresh our browser, we will see the logo. See how easy it is to serve static files? Nice. This is a great result, right? In this video you have learned how to set up a simple lightweight HTTP server. In the next video we will take all of this a step further by processing a post handling post data. Hi and welcome to the last video of this section about handling post data. In the previous video you learned how to create an HTTP server and how to handle requests. In this video we're going to take a look at how to handle post data and how to post data to our server from our console. First of all, we can check if our request is a post. We do that by if request.method equals post. Else just serve our data. When it's a post, we can use the request object. This is also a stream object with data. So request dot pipe. Then with the true library we can transform our post data to uppercase. And then we pipe it to our response. How can we do a post to our server? Well, we can extend our index.js script with some code to perform a post to our web server. Request is a great HTTP client library that we can use for this. So let's install this library. So we go to index.js, and at the end of our file we create a new command. This will execute our HTTP client code. At the top of our index.js file we require request. Now we can start a post to our localhost web server with request.post and then the URL to our web server. This will return a variable. Then we define here a readable stream. And then we can define here a readable object. And then we push our sentence to the readable stream with the push method. Then we need to add the following code. Then at the end we construct our pipeline statement. We start with our readable stream. And then we pipe it to our post. And that we pipe to process.stdout. So we get our output in the console. First we need to start our web server. So we can post something to our web server. And then we can start our post. Great, it works. In this section you learned how to work with streams. First of all, we explored the streaming API of Node.js. In the second video of this section, we looked at object streams and how to work with objects instead of the default strings. Then we built our own HTTP server and served some static content to our end user. In our last video of the section, we covered how to handle post data and how to work with an HTTP client. In the next section, we will use some Node.js libraries to create HTTP and web servers. Hi, and welcome to section 5 about HTTP and web server. In the previous section, we already saw how to set up a web server in Node. In this section, we will look into more high-level libraries that will help you in creating a web application. Now we move on to the first video of this section that deals with express.js, a Node.js library to create a web application. In this video, we're going to take a look at how to handle requests. We will also build a REST API towards the end of the course, and we will serve an HTTP document with a template. First of all, we will convert our server.js file to an Express application. Express.js will use under the hood the Node.js HTTP library. So we need to install Express.js first. Then we need to require the Express library on top of our file. So for Express, Express has a routing algorithm built in. m.get. Then we define our path. Then we have a callback with request and response. The request response is just like in the callback of our HTTP method. Do you see here? Great. Then we can just copy paste or else block here. Now we can do the same for the post method. And then we take our code here in our old method, and we paste it in m.post. So for every HTTP REST option, we have a method in Express. Now we can remove the old method. We can make our code shorter by using the route method. Here we go. Then at the end we need to listen to a certain port, in our case 8080. The only thing that we need to change here is server into app, because it's our Express app that needs to listen to that port. Now let's test this out by doing node server. Now we go to localhost 8080. Great. Remember our post CLI program? We can execute this to do requests to our web server. So we do node index post express. And express brings it to uppercase. So our post method is working too. Let me explain how you can serve an HTML document. In a lot of web application frameworks, you have the option to use a templating engine. In Express, we can do this as well. We can use, for example, Pug. So first of all, we need to install Pug to our project. So with app.set view engine, we can tell Express which templating engine we're going to use. So in our case, it's Pug. Now we create an index.pug file in the views folder. Then we create the following content. First of all, we start with HTML. Then we have a head. In that head, we have a title equals title. And then we have a body. And then we have an h1 element with a message. Then we create a route that renders the index.pug file. So first of all, we use app.get. Then, for example, we say off the path hello. We set a variable title and message to the templating file, and we do that as follows. First of all, we use response.render to render and to use our templating engine. Then we say what the name is of our template file, in our case index. And then we define our variable that we are going to send to our templating engine. So in our case title. Message hello there. Now we can start our server again, and then we need to go to /hello, and then we see here hey in the title and hello there in our h1 element. Now we can also use path variables as follow. And then in the request object we have a variable params, and there we have our path variable. This way we add some dynamic layer to our application. Then we can start our server with node server. Then we add something to our pod. For example, something. Then here we have our title something. In this video you learned how to work with Express.js. In the next video you will learn how to work with middleware in Express.js. Hi and welcome to Request Middleware. In the previous video we looked at how Express.js works. In this video we're going to take a look at how Express.js middleware works. First of all, we're going to explain the Express.js middleware. After that we will write our own middleware, and towards the end we will use an existing part of middleware. Express is a routing and middleware framework. In the previous video we explained already how routing works. Middleware functions have access to the request and response objects, and the next middleware function in the application's request and response cycle. Middleware can perform the following tasks: execute the code, make changes to request and response object, and end the request response cycle. Also, you can call the next middleware function in the stack to go to the next middleware function. With middleware, we can build a logic between the incoming request call and the response back to the end user. It can go over a whole stack of middleware functions. Let's create a middleware function to perform some logging into the console. First of all, we create a logging.js file. In that logging.js file, we will include our application as our middleware that handles the logging. So we start with module.exports, then our middleware function with request and a response object, and then a next function. And in this function we can call console.log time then the current time now, and then it's important to call the next function. It will go to the next middleware function. Can also add some logging about the request part. So for example, console.log Now let me include our middleware to our application. First of all, we need to define a require here to our logging. And now we can include our logging by using app.use. With the use method, we can include middleware to express. Now we can start our server. And then we can refresh our page. This results in the following outcome. You see that he printed out a timestamp, and then here we have our request part. We have a timestamp and a request to favicon. Another approach of Express middleware is the extending of the request object. So here we can use app.use and then our middleware function. And then in this middleware function, we can add a variable to our request, in our case request time. And then we need to close with the next methods. Now we can add a time variable here. And then we can access our request time variable on the request object. We now only need to add our time variable to our template. Now we can start our server. And this is the result. Timestamp of today. You can also use other middleware that is developed by an open source developer. On the Express website, you will find an overview of the biggest and most used middleware of Express. You have a body parser, a cookie parser to handle cookies and error handling. Then you have Morgan for better logging, stir static to server static files, and so on. In this video we will use timeout middleware to set a timeout period for HTTP request processing. You know the drill already. We need to install now connect timeout. Then we need to use timeout. So we need to define a require. And then with the method app.use, we can use our timeout middleware. We set our timeout to 5 seconds, so the middleware will time out in 5 seconds when the request is longer than 5 seconds. Then we can fake a very long timeout. When we then start our server again, we can go to that path that we defined. You will see that our middleware throws an error. In this video you learned how to use middleware in Express. In the next video we're going to show you some information about how to create social logins in a web application. Hi and welcome to video 3 about social logins. In the previous video you learned how the middleware in Express works. In this video we're going to take a look at how authentication works in Node.js with the Express framework. Passport is the authentication middleware for Node and Express.js. It has one purpose: to authenticate requests. Traditional users log in with a username and a passport. With the rise of social networks, single sign-on providers using a no-out provider such as Facebook and Twitter, and that has become a popular authentication model. Let us use Passport and work with Facebook in this video. Now we need to install Passport, of course, otherwise we cannot use that library. Passport works with strategies, so we will work here with local strategies, and for that we need to install two strategies, a local strategy and a Facebook one. Then we need to define a passport.js file. We'll use the following code. In this file you'll find the serialize user and deserialize user method. When we have a database, we can look up the user with the ID in the deserialize user method. In the passport.use, we register the correct strategy for Facebook. In our case, Facebook strategy. The Facebook strategy needs 3 items: client ID, client secret, and callback URL. The passport.use has also a callback. In this case here, a function with a token, a refresh token, a profile, and a done method. In this function we can also do a call to a database to look for the correct profile in the system. However, here we are just demonstrating how a simple Facebook login works in Express.js. If we will do this, it will lead us too far. Now we need to require passport first. Then we need to define a path to authenticate with Facebook. So app.get, then the path to authenticate, Facebook. And then we have here passport dot authenticate with Facebook, and our scope will be email. After that we need to define a callback path. And in here we need to tell what the success URL and the failure URL are. So we can redirect to the correct page of our web application. Then we need to define the logout route for the web application. Remember from our previous video that a middleware can add functionality to the request object. In this case, Passport added the method logout to our request object. Next we can define a isLoggedIn middleware, where we check the isAuthenticated boolean in the request object. When this boolean is true, we go to the next function in the stack, otherwise we will do a redirect. Now we define a protected route. Only when we are logged in, we can access this page. As a second argument, we use our isLoggedIn middleware. And then we define our callback with a request and a response object. Then at the top we need to add some Passport middleware. The usage of session is very important here. So we need to install Express session. This is used to have session handling in Express. Passport needs this, otherwise it will not work. So it's very important. So we define here a variable session. And then we require Express session. We also need to require our passport.js file. So here we define require passport, and as an argument he needs the passport object. We also need to add out.js here. Where we define a client ID, client secret and callback URL. Now that's all. Now we can start our server. Now we can go to the product page. You'll see that he redirects to our login page, but our login page doesn't have a login URL or link to click on. So we need to add that to our index.pug file. So we can add the following link to our login page. Restart our server again. We go back to protected page. Now we are on the login page, so we can click on login. And now we are logged in with Facebook in our application, and we can access our protected page. In the logs you can see that he went to out Facebook and out Facebook callback when he came back from Facebook. That's great, right? In this video you learned how to work with social logins in Node.js. In the next video we're going to take a look at Koa.js, a modern web framework for Node.js. Hi and welcome to the last video of section 5 about Koa.js, another web framework. In the previous video we looked at how to create social logins. In this video we're going to take a look at what and why Koa.js. We will touch a bit of generators code, and then we will transform our code to a Koa.js implementation. Koa.js is a new framework designed by the creators of Express.js. It's also a minimalistic framework, and the footprint of your web application code will be smaller than Express.js. It uses generators that will help in ditching callbacks. Generators is a feature of ECMAScript 6. Generator functions let the end user yield its values. Consumer of a generator function calls the next function to get the next value in the stack. First we need to install Koa. Then we will create a new file, Koa server.js. At the top of our file we require Koa. Then we define a nap variable. Do you already see the similarity with Express? Then we can use app.use. then our generator function, and then we can set the content of our HTML document. In our case, a simple hello world. So every request our server gets will result in setting hello world to this.body. Now with app.listen, we can listen to a certain port, in our case 8080, and that's it. We can now start our server with node koa_server, and then hey, we see a hello world. Koa.js has no router in its framework. For that, we need to install a middleware Koa router. First of all, we need to require our Koa router module. Then we need to use its middleware by adding router.routes and router.allowed methods to Koa with the use method. This is also very similar to Express. Now with router.get we can define our path, and as a second argument we have our generating function. With the parameter next. In this function we are going to read file.txt. For that we need to have two libraries of our path and our file system API. Now we can use the following code. The first line will concat the working directory with file.txt. The next line of code will yield our asynchronous method. Then we will check if the file is really a file, and if that's so, we can set the type by reading out what the type is of the file, and then we can set this.body to a reading stream of file.txt. We can provide this.body a stream object and use the path library of Node to resolve a path on our disk. It will also get its extension with the path.xName method. Koa works with the this.type and this.body. You will see that we yield a static file. This is how Koa works. This is our synchronous method that we're going to call. Now we can start our server with node koa_server. We now refresh our local host. We will see that we get the content of our file. Koa.js is based on ko.js. It's an ultimate generator-based flow control for Node.js. Ko.js is based upon coroutines. Coroutines are computer program components that generalize subroutines for non-preemptive multitasking. By this nature, coroutines are very good when you write asynchronous programs. And that's where Koa.js is for. With cobody, we can parse a post and get the content of the post. Cobody is a library that parses request bodies with generators. You can use it also without Koa.js. We need to require cobody on top of our file. Then we can add a post method. Router.post on the path slash. Then we have our generator function. Now let's write our code to handle the post data. First of all, we need to define a body. And we have the yield function. And then we parse text of this. Parse.text is an asynchronous method. That's why we need to put yield before it. Then we have console.log body to print out the content of our body. Then we can put this.body equals body to upper case. Now we can start our server again. Node Koa_server. Let's test this out with Postman, tool to do API calls, in our case post to our Koa server. You see that it turns out in uppercase. So our Koa server post is working. In this section you learned how to use Express.js to build a web application and how middleware is used in this framework. Also, social logins have no secret anymore for you. In this last video we saw how Koa.js uses generators instead of callbacks to create a great web application. In the next section we will look into accessing the file system. Hi and welcome to section 6 about using Node.js to access the file system. In this section we will look into the file system API of Node.js and how to manipulate the file system with Node.js. We will look at how to iterate over files and folders. We will read and write to a file, and in our last video we will handle a file upload. Now we move on to the first video of this section that deals with iterating over files and folders. It's great to have you here. In this video we're going to take a look at the file system API of Node.js. We will expand our CLI application so we can search for the biggest file in a folder. Another big core library of Node.js is FS, and it stands for File System. It has a lot of great functionality, from checking if a file exists to changing the rights of a file, to append content to a file, and so on. It is a file I/O library of Node.js. The library itself is just a simple round to standard POSIX functions. All the methods that FS provides have a synchronous and an asynchronous form. The synchronous form requires a callback as its last argument. On the Node.js website you'll find the necessary information about all the options that the API brings. Let's create a command in our CLI program that searches for the biggest file. First of all we need to require file system API on top of our file. With fs.readdir we read a directory. So fast.read there. And as a first argument, we can use search path. And as a second argument, we have a function that has error and files as arguments. And then we need to check if we have an error. When we have an error, we need to exit the program. We can do that by using the global object process, and that has a method exit to stop our application. We also need to warn the user with console error. Then we need to iterate over all the files. So files.for each. And then we have a callback function, file, index. In the next step, we will use the path API of Node. So with this path API, we will construct or complete path to our file. On the path API, we have a join method. And as a first argument, we can provide our search path. As a second argument, we can provide our file name. And then we can define a function that gives us the file size of our file. We can do that with the method statsync. With statsync method, we can get a lot of statistics about our file. Then we can define variable file size. We call our new function. And we provide a complete path to that function. Then we will check if the file size is bigger than our biggest file until now. When that's the case, we assign our file size to size and to our file name, current file. At the end, we print out our result. Now in the folder files, we have 3 files. 123.txt, lorem.txt, and small.txt. And in lorem.txt we have a lot of text. In small we have just ABC. And 123.txt we have some text. When we test this out in our console, we get the following result. Chooses lorem.txt. So it's working. In this video we search between files and use the information of the files to provide you the biggest file. In the next video we will read from a file. See you there. Welcome to video 2, reading a file. In the previous video we looked at how to iterate over a directory and get some file information in that directory. In this video we're going to take a look at how to read a file and how to watch a file. We will react upon changes in a file and show you how to do this. In Node.js we can read a file. We already saw that in the previous section about streams. In this video we will use another API. So first of all, let's create a new command in our CLI program. In the file system API we have a method readFile. As a first argument we can provide the read path to our file. As a second argument we are using UTF-8, that's our encoding. And as a last argument we have a callback. When the reading is done and we have our data, like we saw in the previous video, we need to check if we have some errors. And if we have some errors, we need to return console.log with an error. Just another way to stop our application. Then we can print out the result and put that result into uppercase. That's quite easy, right? Then we can execute our command as follows. But we can do much cooler stuff. So, how can we watch a file and its changes? Well, we can do this with the fs.watchFile functionality in our file system API. Keep in mind that this API is not consistent across platforms. So let me show this to you with a new command watch. And in this command we will use fs.watchFile. As a first argument we will use read path, and as a second argument we have a callback. The first, here current, is a current file, and previous is a previous file state of our file. And we can do some printouts, for example, console.log the current mtime is the previous mtime was so every time our file changes we have some metadata about our current file and our previous file. For example, the time when it was being changed, and then we can read our file again. So we can do read file or read part. Then we need to specify our encoding, and then we have our callback. we need to check if we have an error. And when we have an error, we need to stop our application. So what can we do now? Well, we can do something very cool. We can check if our file has the word beep. Yeah, you heard it correctly, the word beep. Why the word beep? Well, if we have the word beep in there, we will fire off a system beep. Yeah, indeed, you can fire off a system beep. You can do that by printing out the following character to our console. Now we need to open up a real terminal of our Mac, and we need to execute the following command. Now we are watching small.txt. Now we can change something in small.txt, for example something, and this will do nothing. It will only print out some statistics in our console. This results in the following outcome: the current time that the file has been changed and the previous time. Now let's go for the beep sound, right? By typing in beep and saving the file. Here we go. We have a beep. Cool, right? It's much better to use fs watch instead of fs watch file. So let's change our code accordingly. We need to change watch file to watch. And then as arguments here in our callback, we have event type, and we have file name. Then here we can change it to event type is event type. We can remove this, and then we can check that we have a file name. When we have a file name, we can read the file again. And we can print out here Now when we go to our console, we can execute our command again. Now let's go to our file and let it beep again. Shokidar is a great wrapper around the watch methods of fs. It uses the event system of Node.js, so an assignment for you is to rewrite our code with this library. Have fun! In this video you learned how to read and write a file. In the next video we will manipulate and write a file. Welcome to video 3, writing a file. In the previous video we looked at how to read and watch at a file. In this video we're going to take a look at how to write to a file. First we need to see if the file exists. If the file doesn't exist, we need to create a file, and then we need to write the content to a file. In one of the previous videos we already used fs write stream to write to a file with a stream writer. In most cases that's been preferred. In this video we will see another way to write to a file. It's important to know all the ways to write to a file. So first of all we need to create a new command. In our case we will create the write command. First of all, we need to see if our file exists. We can do that with fs.stat. As a first argument, we need to provide our write path, the path where to write the file to. And as a second argument, we can use a callback with error and the stat object. Then we need to check if we have an error. So if error n it's not a file, we need to stop our program. We do that with process.exit 1. Now we can write to our file, right? With fs.write file, and then as a first argument and then we have a callback with an error object, and then we need to check if we have an error. It's always the same. And then we need to stop our program. Or anticipate to our program. In this case we stop our program, but it's not always necessary to stop your program. And at the end we can just read our file and give that content of that file to the end user with read file. And then a callback. We can check for an error. And then if we have an error, we need to, yes indeed, we need to stop our program. That's correct. We can do that with process.exit, or we can do that with return console.error. Now we can test this out in our console. Great. If you now look to file.txt, you will see that we have here nice try. File System API is a very straightforward API. We can also write a script that copies all the content of one directory into a new directory. This will be a small summary of what we saw before in this section about the File System API. So first of all, we need to create a new command. And this command will be move. First of all, we need to read the directory of our from directory. We have a callback, an error object, and a files object. We first need to check if we have errors. And then we need to stop our program. After that, we need to iterate over our files. We do that with files for each, and then a function with file and index. Then we create a from part, and we create a to part where we join our to directory with our file. And we check the state of our file. We have our callback. We have our error statement. We can just check if it's a file or a directory. After that, we can just rename the files to the destination part. We do that with fs.rename from part to our to part, and then we have callback function with an error. If we have an error, do a console.error file moving error with our error objects. Otherwise, we just print to the end user that we moved the file to from part to part, and that's it. Now we create a destination folder, and then we run the following command. Great, our files moved from files to destination folder. Great, our script is working. In this video we have learned how to write to a file. In the next video we will handle a file upload. Hi and welcome to the last video of this section, handling file uploads. In the previous video we looked at how to write and move files. In this video we're going to take a look at how to adapt our HTML page so we can upload file. We will tell you more about the form multipart, and we will refresh your memory by writing the file with streams to an upload directory. So when you want to implement a file upload, we need to adjust our HTML plug template and add form with multipart. So form with a method post. An action upload, and then an encoding type of multi-part / form data. And in this form we have an input with the type equals file, name, file upload, and then we have our submit button. The content type multipart / form data is being used when we are going to upload a file to the server. In Node.js and Express.js you have a lot of middleware components that can handle multipart upload. Busboy, Busboy Connect, and Formidable are just a few. We will use Connect Busboy in this video. In server.js we need to define a new path, a /upload path. We can do that with app route /upload, and then .post rec res next, and then our function. Then we need to install our middleware connect busboy. Then we need to declare it on top of our server.js file. So /busboy require connect busboy, and then we can use that as a middleware. So we can do app.use busboy then we can pipe our requests to request.busboy, the busboy object. Then we will declare a variable var fstream. We will use it later. And then we have on our request, or on that busboy object has an event called file with a function with arguments field, name, file name, then we can print uploading file name now we can create our file stream. Create write stream. Then we take our directory name where we're in, and then we have our upload folder, and then our file name. Now we can pipe our file to our file stream or write stream. On our write stream, we have a close event, so we can do on close. We have a function, callback function. And let's put some logging, console.log, upload, finished, of file name, and then we can do a redirect to a success page. We create a pug file for that, success.pug, with the following content. Then we need to create a route method for our success page. We also need to create our upload folder. Now we can start our server, node server. Great. Now we can just choose a file. For example, cappuccino. We can submit this file. Well, it didn't match, so we need to put here a wildcard to fix it. When we restart our server again, node server, then we refresh our page. We choose our file, cappuccino. We submit it. You will see that we have a success. Your file has been uploaded successfully. Let's take a look under our upload folder. Yay! We have a cappuccino.jpg file. It's working! In this section we have learned how to iterate over files and folders and search for the biggest file. We looked into reading and watching a file. After that we learned how to write a file and how to move the files from one directory to another. In the last video of this section we saw how to handle file uploads and refreshed our knowledge how to use streams to write a file. In the next section we will see how to set up multiple processes and how to interact with all these processes. Hi, and welcome to section 7 about utilizing multiple processes. In this section we will look at how you can use the process object to get more grip on your Node.js program. We will use multiple child processes to give them extensive work. In the last video of this section we will perform communication between our different processes. Now we move on to the first video of this section that deals with taking control over the process. In this video we will look at some useful events and how to interact with them. In this video we are going to take a look at how to use the process object and how to look at an event from that process object. We already saw a little bit of the process object in the beginning of this course. The process object is global. It is accessible without the need of a require. With the process object, we will hook upon certain events of our Node.js program. For example, when the Node.js program wants to stop or when an unexpected error occurs. Let me show you some events of the process object. We will start with the before exit one. This event will be fired before we exit our program. It's very logical, right? Normally the Node.js program will stop when there is no work scheduled anymore for the program itself. We hook up on the fact when a program wants to end with a before exit event, like I showed you now. Another event is the process.on exit 1. This is fired when we really exit the program. Keep in mind that you can only perform synchronous code here in our exit event. It's very important to take that in mind. Additional work that you want to do here for the event loop will be abundant. Let me show you with an example. For example, we can put some set timeout functionality here. Put in this will not run, and we set our timer to 0. Remember that set timeout was also in the set of operations list of the event loop that we saw before. When we now execute our program, we will see the following result. Well, when we change the 0 to, for example, 5, it will take 5 milliseconds to execute this asynchronous code. You will see that he will not execute this asynchronous code. That's because our program has been stopped. You can also see the sequence of execution. First, the program prints out your program is going to stop, and after that it's about to exit with code. Another event that's very important is the uncaught exception event on the process object. So every time something unexpected has happened and there is some kind of error, you can log it here, or you can do something special here in this event. It comes in very handy when you have some kind of debugging problems. When your application, there is something that happened with your application and you really want to see what or how, or then you just can print out here the error. In this video you learned how to use events of the process object in Node and did some refreshment on what the process object is. In the next video we will create a child process to offload our work. Welcome to the second video of section 7 about creating child processes. In the previous video, we looked at some events about the process object. In this video, we're going to take a look at what child processes are. We'll give you an overview of all the different processes that you can spawn or that you can start from. We can execute a process, we can spawn a process, we can whatever what. First of all, let me explain to you something about the child processes. Node.js runs in a single-threaded mode, but with its event-driven paradigm, like we saw before. It can handle concurrency. It also has the opportunity of the creation of child processes to the leverage of parallel processing on multi-core CPU-based systems. Every possibility is implemented on top of child process.spawn. So the first child process.exec spawns a shell and runs a command in that shell. Exec file will directly execute the command without spawning shell. Then we have child process.fork. An EPC command or EPC communication channel is established to perform communication with your child process. Now you have the synchronous versions, which will block your program until the child processes are executed and stopped. Let me show you an example. We can start with creating a new command in our program called Node version. In this command we can start a new child process that will execute Node-v to ask for the Node version. The response of this command will be sent to stdout in our callback. When the program gets an error, it will be sent to stdr. First of all, we need to require child process. That we can create an object exec. Then we can use exec to perform Node-v, and in the callback of that function we have an error, we have stdout, and we have stdr. We'll print it out to our console log. We can do the same for stdr. And then if we have an error, we can print it out and explain to our user that we have an error. It's very simple, right? You can just execute command line programs like Node-v here. Now we can execute our program in our terminal. Node, index, and then Node version. The result is great, right? It's what we expected. It prints out the version of Node. Now imagine that we want to execute a JavaScript file from one Node application to another Node application. Well, we will do that by creating a support.js file. And in its support.js file, we will put a console.log Now we'll create another program command, in our case child. This program will spawn 3 child processes with the exec method. So therefore we need to create a loop we'll create 3 spawn processes. And then we will use our child process node, name of our file support.js, and then our index of our loop. And then we have our callback. Like we saw before, we have error, std out, and std error. And then in the callback, we can put some logging. Some logging when an error occurs, and then the std out and the std error. The work process object has also an event. An event exit. It's important when we want to know when our child process has been stopped or when it's been done with performing his functionality. Now we can execute our program in our terminal by typing index child. And this is our outcome. You see, our program exited, and then we print out child process 0. Then we have child process 2 executed, and then child process 1. So they're not executed in the same order. Now we will change our code to use spawn. Do it like that. Use spawn, then node, then we need to provide the arguments of node, in our case support.js and I. And then we need to close it. Then we can remove this one. And on the worker process, we also have some kind of events. So our worker process has an object std out, and we have here an on event of data to receive some data. We have the same for error. And instead of exit, like we had before, we have an event close. It's important to remove the spaces, that we really have that name that we want to call to. Otherwise we get an error in our terminal. Now we can just perform node index child. And this will give us the following result. It executed 0, 1 and 2 after each other. In this video you learned how to create child processes. And in the next video we will dive into the communication between child processes. Hi, and welcome to the last video of this section about communicating with your child processes. In the previous video we looked at how to spawn and create child processes. In this video we're going to take a look at how to communicate with these child processes. We're going to create and compose multiple processes, and then we're going to communicate by IPC to these processes. Imagine that we want to catch everything that we send to the console and save it in a file. We can create two child processes that handle the writing to a file and one that writes the text to the console. We will start with creating a folder called processes. In this folder we will create two files, one with the name writing.js, to write everything to a file. Now we can place here our code to write to a file. In our case we will write everything to log.txt. So this is our child process. And to communicate to our parent process, or to get messages from our parent process, we can use an event on the process object. It's called the message event of the process object. And then we have a callback where we have our message. And then we can write our message to our log file. We also need to create our log.txt file. Next thing we need to do is create our second child process. We'll call it console.js. The console.js file will send a message to the console when it's listening to a message event that's been sent by the parent process. To do that, we need to start with process.on to listen to the message event. And then in our callback, we will write the message to the console. Now we need to move to index.js. This will be our parent process. On top here, we need to declare child processes. And we need to fork our child process. In this case, our console process. It's been located in the folder processes. The same needs to be done for writing.js. So we can copy paste this line. Change it to writing.js. Take a very close look at fork. With fork, we'll create a child process that has the opportunity to communicate with underlying processes. Fork is very important in here. Then we create a method or function that will combine our sendings to our child processes. We will call it combine sendings. It's very original, right? And then we take our console process. On that object we have a method send. And then we can do the same for writing process. With the send method, we send our text to our child processes. Now in one of our programs we can change print, for example, to combine sendings. Now when we execute this with node index high, you will see that it prints it out into the console. And when we go to log.txt, you will see here, hi, welcome to our program. I am Angelica. Nice to meet you. That's great, right? So we communicated from our parent process to our child processes. One of console.js and one of writing.js. One that writes the messages to our console, here. Then one that writes it to a file, here. So to summarize what you learned here, we can create a child process to communicate with the fork method. We send something to another process by calling the send method. Then in our child process, when a child process wants to listen to a parent process, we use the .on method and listen to a message event of the process object. So in this section, we saw how to create a child process. And then in the last video, you learned how to communicate between these child processes. In the next section, you will learn how to create a real-time application in Node.js. Hi, and welcome to section 8, creating real-time applications. We will see how to create and build real-time applications in Node.js. In this section, we will use socket.io, Node.js library to work with WebSockets and perform bidirectional communication we will dive into server-sent events and look into server-to-server communication with UDP. Now we move on to the first video of this section that deals with bidirectional communication with Socket.io. Socket.io is a library for using WebSockets in Node. In this video we're going to take a look at what WebSockets are and how to use them in Node. We will see how to establish a bidirectional communication between a server and a client. WebSocket is a computer communication protocol. It's a complex protocol that was standardized in 2011 by the W3C. It provides a full duplex communication channel over a single TCP channel. With a WebSocket, you can send a message from a server to a client. You can also send a message from a client to a server. On the Mozilla Developer Network, you'll find more information about the WebSocket API. In Node.js, it's also possible to use WebSockets. Socket.io is the most famous framework to deal with WebSockets. It's a framework to create a real-time application in Node.js. So, let us take a look how to create a real-time application in Node.js with Socket.io. First of all, we need to install Socket.io into our project. We do this with npm i socket.io. We also need to install Express because we are going to serve HTML pages through Express. First of all, we need to create our server.js file. On top of the page, we need to instantiate our Express application. Then we need to declare our server variable. Now we can start with a specific Socket.io code. First of all, we declare an IO variable where we require Socket.io, and we pass the server variable to it. The IO variable has a lot of events that it can listen to, and one of them is connection. This is fired when it establishes a connection. So we have here io.on and then connection and then the callback. This callback has a socket into it, so every time we have a connection we get a socket variable back. That's our bidirectional socket that's being created here. And of course, we also need to listen to a port. Now we can emit an event. So let's do that. Socket.emit an event with some data. You get my point, right? This way it's very easy to send some data to the client with socket.emit. We also need to serve an HTML page. So now we can use Express for that. We do that with app.get, like we saw before. And then with our response, we send a file, in our case index.html. Now we need to create our index.html page. Here we go. And then we copy paste the following code into it. It has an editable section. And that's it. So in the body, we add the following code to connect our client to our server. Then we create a variable socket that will be equal to IO. Notice that we are not specifying an URL when we call IO. It tries by default to connect to the host that serves the page. Next, we're going to add a method that reacts upon changes of our editable content. These changes are key up, paste, copy, cut, delete. Content editable attribute is an HTML5 attribute, so it's not available on every browser. Keep that in mind. And now we need to declare a div. Where we grab our editable content div. And then we will use our method setChangeListener. We'll pass as a first element the div, and as a second element we will have our callback. So every time the content editable will change, we will come here in this setChangeListener event, and here we can send a message to the server with socket.emit content change, and then we pass the inner HTML of our editable div. Now on the server, we need to listen to that event, right? So here we just pass console log, where we say that the user is connected, and then on our socket we can listen to content change. That's the same name that we declared in our client. Then we have a callback function which contains the message. And then we're gonna print out this message to the console. Now we can start our server to see the result. So this is our result. Now when I change something here, you see it sends an event with a new content over here. Now we want to update the other browsers when somebody updates the content. So let's update our code and emit the content to the rest of the users. With socket.broadcast.emit will send the message to all the other sockets that are listening. Now on our client, we need to listen to this event. When we got a content change message, we set the content of our editable div to the value of our message. We do this as follows. Socket.on, then content change, and then we need to set our div inner HTML to message. So we start our server. Now we opened two windows, and in the one window we can change something, and you will see that it reflects on the other window. So let's change 3 items into last item. That's great, right? We created our own collaborative editable document. In this video you learned how to use WebSockets with Socket.io in Node.js. In the next video we will dive into server-sent events. Welcome to the second video of this section about server-sent events. In the previous video we looked at bidirectional communication and how to use WebSockets in Node. In this video we're going to take a look at the server-sent events API of the web. We will use Redis to help us to create a pub/sub channel. We also adapt our content editing platform from Socket.io to server-sent events. Server-sent events are an alternative to WebSockets. It's also a web API that we can use. Server-sent events is a technology where a browser receives automatic events from a server via HTTP connection. It was also possible before, but the client would have to ask if there are any updates available with a timer. This is very inefficient. WG works on this specification. So for this we will create a new file, server ssa.js. And we will start with the content of server.js. We also need to install some packages. First of all, we will install body parser. In our example, we are going to use Redis, a key value store. It has a backend functionality for the publishing subscribing mechanism. So let's install that too. Great. So now we can declare our Redis object by requiring it at the top of our file. We also need to declare and require our body parser. Now we need to use it in our middleware of Express. So with app.use, we can instantiate it, and we can use bodyparser.json. And we can set the URL encoded with an extended on true. Now we create a new route where we listen for new messages. And then we put the following code into our update stream route. Let's explain to you what this code means. First of all, we need to create a new client. It's our subscriber. We subscribe to updates. When there is an error, we load this. And then when there is a message, we increment our message count and rewrite our message count and our data. The most important part of a code are the headers with content type text, event stream. We put a cache control of no cache, a connection keep alive, and the access control allow origin to everything. Also the write of retry 10,000 is very important. Then we have our close event. The close event is fired when a user closes their browser window. In this situation, we want to make sure our Redis channel subscription is properly shut down to prevent memory leaks and incorrect subscriber counts to the channel. Then we will create our fire event endpoint in Express. When we access this endpoint with HTTP client, we will update our publish client and we will write something to the end user. The most important part is the publisher client.publish, where we publish our message into the subscribe publishing mechanism of Redis. Then in our index.html page, so in our client code, you need to put the following code. Start with a source. It's a new event source. And this end path is update stream. So this is our event listener, and we add our e.data to the div.innerHTML. We also need to install Redis. Keep that in mind, it's important before it can work. Now we can start our Redis server. First we go to source, and then we do Redis server. Great. Now we can start our server send event server. Now we can go to our new endpoint that we created, our fire event. And we can put some content into our editable content. That's great, right? Then when we want to extend this, we can just add here something extra. In this video we learned what server-send events are and how to use them. In the next video we will look at server-to-server communication. Hi, and welcome to the last video of this section about server-to-server communication. In the previous video we looked at how to use server-send events. In this video we're going to take a look at what UDP is and how to write a code to perform server-to-server communication. UDP stands for User Datagram Protocol. In networking layers, it stands next to TCP, Transport Communication Protocol. UDP is used to send messages from one computer to another. In this video we're going to use UDP for server-to-server communication. The client will watch at the changes in a file and send a message when a file has been changed to the WebSocket server. The server will accept messages and send the content to the browsers that are listening. We start at the top of our JavaScript file with declaring dgram. Dgram stands for datagram. Then we will create our UDP server. We do it like follow. On dgram we have a method create socket UDP4. When we have some errors that occur when we get a message, we need to log them and close our UDP server. We do that as follow. We have an error event in our UDP server, and we do console.log, and then we close our UDP server. Next thing we need to do is use the message event. We do that with on message. Then we have a callback to message in it and our info. Then we have an event that listens when a connection has been made. Then of course we need to bind our UDP server to a port. Our message from our UDP server, we put it on our Redis publisher client. So we're going to use our publisher client. Then we use a method publish. We define updates as our channel that we're going to use, and we send to that channel a message. This will trigger our server send event from our previous video. This is nice, right? Now we need to create another server. And in this other server, we will watch a file content.txt, and we will send the changes to our server SSE. And this is the code that we're going to use for that. At the top, we declare a tgram. Then we have a client that creates an UDP4 socket. We also use a file system to watch the file content.txt. Then we see if there are changes. And if there are changes, we send the content of the file content.txt to our server. Now we just need to create content.txt. And now we can start our server. We can also start another server. Now, when we put something in our content.txt file, we need to see that reflected in the browser here. So put something in here. And now we save it. And here we go. We have our content. This is some awesome content from content.txt. It's great, right? Oh, I like it. Great job so far. In this section, you learned how to write bidirectional communication with Socket.io. We looked into the server send event protocol, and in the last video of this section, we saw how to write server-to-server communication. In the next section, we will look into scaling our application. Hi, and welcome to section 9, Scaling Your Application. In this section, we will see why, how, and when we need to scale our application. In this section, we will look at the why around scaling, and at microservices in Node.js, and we will bring a Node.js application to the cloud. Now we move on to the first video of this section that deals with the why about scaling. Scaling is a term that everybody has heard about. We will go deeper into the term and tell you why and when you need to scale. In this video, we're going to take a look at what about scaling. We will go through all the stages of scaling, the vertical and the horizontal scale. Because before we are going to scale a Node.js application, we need to know what scaling is all about. What about scaling? Massive success is the best that can happen to any application. Also to your application that you're going to build right after this course. This can be a blessing. We need to deal with high availability and avoid downtime. It's very important to scale when your number of users are growing and that you do it carefully. We'll use the term concurrent user here. That means the users that are hitting our application at the same time. Never scale too early. It will cost you a lot of money and also wasted effort. So first of all, we have some levels of scale. When we go to the next level, it depends upon the number of concurrent users. It's important to have some statistics around that in your infrastructure. So when you are the only one using your application, testing your application, and you don't want to show it to the outside world, you can stick with localhost for now. When you are confident about your application, you can put your application on a server in a hosted environment or in the cloud. Just one server, or the minimum requirements of a cloud instance. That's a good solution for demonstration purposes. The moment you have 9 simultaneous requests, your application is ready for the next phase. The next phase is vertical scaling. When you talk to your friends, you advertise a bit on social media and you get some buzz. Your application is hitting 10 to 99 concurrent users this time. Web pages are getting slower to load. It's time to get a bigger box. We need to extend our single server with more resources. This is called vertical scaling. You simply make the machine bigger with higher, faster CPU, RAM and HDD. You can run 2 instances on this single server, and with an internal load balancer, you can balance the requests between each other. When one instance goes down, you can point all the requests to the other one. This will have an advantage that you will increase your availability. It looks like your hard work has paid off and you are reaching thousands of concurrent users. Imagine that. That would be great, right? After some time, the application gets slow again. Most of the time, I/O is the bottleneck. The database responds slower, so we'll increase the number of CPUs. When we do this, we are talking about horizontal scaling. There is a point where vertical scaling is not cost efficient anymore, and you need to switch to horizontal scaling. Vertical scaling has another issue. You put all your eggs in one basket. When the server is down, your application is down too. We can separate our database from our application. This can also be a big win. This will be done in this step very often. And then, when we are very popular and we have more than 1,000 concurrent users, we can go for a multi-server strategy. We'll split our architecture in an application units and start using multiple load balancers. Also, the splitting of responsibility is very important in this case. Bringing your statistic files to, for example, a content delivery network or CDN. Going from one monolithic application to multiple small Node.js applications is another important strategy. This strategy is called microservices. We will dive into more details about it in the next or one of the next videos. In this video, you learned some theory around scaling. In the next video, we will dive into writing microservices with Node.js. Welcome to the second video of this section about microservices that scale. In the previous video, we looked at why scaling. In this video, we're going to take a look at what microservices are and how to use them in Node.js with the framework Loopback. One of the software architectures that helps you scale is microservices. When you have one big monolithic application, it's important to split that up into small microservices. A microservice is responsible for one single domain. So when one microservice is going down, it's only that small domain that is missing. And when your application is resilient, it will still work. This will make your application and your infrastructure more robust. When you have an application that works with orders, you also have users and user data that involve these orders. These orders may be orders for a certain product, so at the end you will at least have 3 microservices. One for managing our users, and one for the orders itself, and one for the products. A great website to look into the microservices architecture patterns is microservices.io. It's a great resource to look at it when you want to dive in a little bit more later. In this video, we will use Loopback, an enterprise-ready framework. It has scaffold functionality and it's great to start from. First of all, we will create a folder APIs. This folder will contain all our microservices. Loopback comes with a handy global tool, so first of all we need to install that tool. We install it with npm. This tool is called Strong Loop, because before the time Loopback joined IBM, it was being under the couple of Strong Loop. Great. Now we need to go to the folder APIs. That's where we are going to generate our project. And we're going to generate it with the following command: slc loopback. This will result in a menu with a lot of options. Under the hood, it's using Yeoman to generate your application. We will walk you through the wizard. So what's the name of our application? Well, our application, we will call it users, because it's responsible for the users. We will give it the directory of users. We'll use the second version, and then we will use Hello World project. Under the hood, generate your necessary files and do an npm install. So now we need to change our directory to users, and then we can create a model. But before we can create a model, we need to create a data source. So we're going to create a data source. You'll also notice that he created a folder with a lot of files in it. We create a data source with the following command: slc loopback data source, and then the name of our data source. For now, we will choose an in-memory database. It's the easiest one. And when we take a look to the data source file, you will see that he created a database in memory and a user data source. The name user data source, local storage user data source, file users, and a connector memory. So next thing that we need to do is creating our model. We do that with the following command: that's quite easy, right? Loopback model. We use as a model name user account. It will be in memory. We will use user data source. It will be persisted model. And we will expose it through a REST API, so we can access it in our web application. And then we type in the plural form of user account. User accounts. We will for now just generate the server side. And then we start with typing in username as a field property. This will be a string and it will be required. And as a default value we will use anonymous. Then we will use field create data. This will be a date. And it will be required. And then we will use source. This will be a string. It will not be required. Now we will stop with creating property names, so we can just type enter. It's quite easy to build up our model like that by following some wizard. So next thing that we need to do is start our server by node. Then when we navigate to localhost Explorer, we can see all our different API calls that we can do. So in our case, we are interested in user account. So we can go to user account, and then we have a post to create, for example, a new user. Now we will use this in our real-time application. So we will go to our real-time application and we will open server When we go then to our API, we can just copy paste this and start one with u/user. Then at the top of our JavaScript file, we need to require request. And we also need to install request. Great. And now we can do a post to our API server. Now we can use the following code to perform a post to our API server. This is a path where we do a post to API/user accounts with the following variables. Username, where we pick the user out of the path variable of our URL. Then a create date of now, and then with the source browser. Now we can start our server with node server SSE. The next thing that we can do is going to the following URL. This will create a new entry in our database with the name Joris Hermans. Next thing that we can do is go to another URL with another username. For example, what name? Just call name. And then when we go to Strong Loop API Explorer, and we go to Get User Counts, we have two entries, one with Joris Hermans and one with what name. That's great, right? Now we can easily register users for our application throughout another Node.js application. In our case, the application user account. In this video, you learned what microservices are and how to create a microservice in Node.js. In the next video, we will look at how to bring our application to the cloud. Hi, and welcome to the last video of this section, Bring an application to the cloud. In the previous video, we looked at how to create a microservice that scales. In this video, we're going to take a look at what the cloud support is that we have in the big landscape of cloud providers. And we will prepare our application for the cloud with Docker, container technology that ships your infrastructure to the cloud. All the big cloud providers support Node.js. AWS has its own SDK for Node.js to talk to its services. This will lead us too far to dive into the services of AWS in this course. It's for sure something interesting to look into after this course. Another great technology is Docker. You can create your own Docker file with all the necessary steps, and a lot of cloud providers have support for Docker. Docker is a container platform where you can define your infrastructure and ship it to the cloud. DigitalOcean, for example, has support for Docker. A very important file to get Docker working is a Docker file. But that's quite logic, right? At the top of our Docker file, we need to add the image that we will use. In our case, it's Node Ergon. You find a lot of images in the Docker hub. Then we add some lines to create our app directory in our Docker container. Then we copy our JSON file, our package.json file, to our working directory. And then we run the command npm install to install our npm modules at our Docker container. Then we copy all our project files to our working directory. We also need to expose a port number. In our case, 8080. And then we need to run the command npm start. Command will start our application. But before this can work, we need to add something to package.json. So we go to package.json and we add scripts in here. And then here we add the start command with node server.js. At the same location as our Docker file, we need to add a .docker.ignore file. In this docker.ignore file, we put node_modules and we put npm-debug.log. But wait, this will not work. Are we not in the need of a Redis instance for a real-time application? Well, you're right. But Docker can solve that for us, right? That's just the power of Docker. Ship your whole infrastructure to the cloud. So first of all, we need to run this command to install the Docker image to our local PC. You will see when we execute this command that he downloads the images that he needs from the internet. This can take a while. With the following command, docker build -t section 9 dot we can build a Docker image. With the -t, we can give the Docker image a name, in our case section 9. This will make it easy to find it back in the future with the docker images command. So let's fire this command. Great, we built our image. Now we can execute the command docker images. And we see here the image name section 9. When we want to combine and compose services, we can use docker compose.yaml file. So let's create that file. And then we add the following YAML content to our file. We'll see here that we use our section 9 build and also our Redis image. And we say here that section 9 depends upon Redis. You can also forward certain ports. In our server.js file, we have used 3030. So here we use server.listen 3030. So it's very important to put here 3030 as a port reference. Then in our console we can use docker compose up. This will start our composition of section 9 with Redis. Our server is running on 3030. That's great. Now we have an environment running with Docker, Node.js and Redis. With this setup we can ship our container to the cloud. Kite is a very useful application that helps you in managing your Docker applications. On the left you see all the containers that are running at the moment. And when we click on one of them we will see more details about our instance. So here, for example, we see more info about our Redis instance that's been coupled to our other instance of our web application. Here we see that our web application is running, and when we go to settings, you will see on which node version it's running. In our case it's running on node version 4. Then when we go to the ports, we will see the address where our application is running on. So now we can click on this IP address, and this will launch our application. Then I can click again to launch another application. And then we can add another number. And when we go here, we'll see another number. Just another number. And when we go here, see just another number. Great, our application is running in a Docker container. In this section we have learned how to scale your application by giving you some theory about scaling your application. We look into writing microservices with Loopback, and at the last video we covered how to put your application into the cloud with Docker. So in the next section, the last section of this video course, we will look into testing and give you some references. Hi and welcome to section 10, testing and references. In this section we will see how to test our code, and we will give you some reference material so you can explore the wonderful world of Node.js even more. In this section we will look at testing frameworks, and we will dive into spies. We will see how to test some REST APIs, and we will also give you some reference sites, what to do next after this course. Now we move on to the first video of this section that deals with testing and spying. As a programmer, it's very important to test your code. It will help you to verify your business logic, and when you change your code, it helps you to remind you that certain rules that you have been applied to your code. In this video we're going to take a look at the differences between Jasmine and Mocha. Then we will show you how to spy on an object with Jasmine. At the end we will provide you with some information about some other tools that are very handy when you are setting up your environment with a great testing suite. In Node.js we have some testing frameworks. The two most famous frameworks are Mocha and Jasmine. I want to show you how much these frameworks look at each other. They have some small differences, so first of all we will install Mocha. Mocha allows you to choose your assertion library. In our case we take Chai, so we need to install Chai. Great. Next thing that we need to do is create our Mocha test. We do this with creating a new file, mocha_test.js, and then in that file we will define Chai, and from Chai we will use should. First of all, we need to describe our test. So we'll start with describe. We name our test suite array because we are going to test something around array. And then we will describe a specific function of array. Our test always needs to start with it. Then we need to describe what we will test. So should return -1 when the value is not present. Then we have a callback, and in that callback we will have our test. So we test that index of 5 should equal -1. Chai is very describable. Foo should be a string. Foo should have length 3. So it's really great to read, and that's just fantastic. So before we can run our Mocha test, we need to install Mocha globally. This will allow us to use the Mocha command in our console. So with mocha_test, we can execute our tests. This results in the following outcome. You can see the same structure as we did with describe, and then our test itself, with a great explanation of our test. Now we can do the same with Jasmine. So first of all, we need to install Jasmine in our project. We also need to install Jasmine globally. Then we can use Jasmine init to initialize our project. You see that we have a folder now with specs, and then we have a jasmine.json file which describes the setup of Jasmine in our project. The next thing that we can do is create a Jasmine test. Do you see the difference in code in our Jasmine test? Well, it's hard to spot, right? Take a good look at the assertion code. Indeed, it uses expect here. But the syntax of Jasmine and Mocha are much alike. We now can run Jasmine with the following command. Just type Jasmine. It doesn't recognize any specs. That's because the name of our file. We need to rename it, and we need to add _spec to it. When we run it again, we will see that he found one spec. That was not hard, right? Quite basic. Well, let's go further with Jasmine, and let me tell you how to use spice with Jasmine. If we look at our JavaScript file, where we use an ECMAScript 6 class that has a function that we don't have under our control, in this case a random number, in some cases a HTTP client request, then we can use spice to force a return when that method is being called. We can add a useWeapon method to our bond class, and this method will use the SomeNumber method. Now let's create our test in our specs folder of Jasmine. We call it bond_spec.javascript, and at the top we declare bond, and we require our bond class. After that, we declare a skeleton of our test. Then we can declare a fake bond object. Then we define a spy over our SomeNumber method. Then we will call use weapon. And then we will expect when we call fake bond dot some number to have been called. So here we test that some number is being called when we call use weapon. That's great. And now we can run our test suite again. We have 2 specs and 0 failures. That's great, right? Now we can test that a certain method is being called, but we want to test the internal behavior too. So how can we do that? Let me show that to you. Well, we can force a return type on our SomeNumber method. We know that this method can result in a 0, 1, 2, 3 or 4, but we always want to have the result 2. First of all, we need to define or spy on another way. We can do that as follows. Spy on, then our object, and then our method name. So our return value always need to be 2. Then we need to capture our return value of use weapon in a variable weapon. And then at the end we can check with expect that our variable weapon will be a Walter ppk. Well, when we go to Bond.js, we'll see that our second choice is Walter ppk. So, okay, let's run this test again with Jasmine. This is great, right? We have 2 running specs and 0 failures. With spies, we can see if a method is being called or not. And we can control his return value if we want that. In this video, we have learned how to test our code in Node.js. In the next video, we will dive into testing our REST APIs. Welcome to the second video of this section, Testing an API. In the previous video, we looked at how we can test our Node.js applications and use spies to work with mocking. In this video, we're going to go a step further and we're going to mock our APIs. Imagine that we have a very nice REST API. Well, how can we test this API? A great way to test this is to test and mock this in the library supertest. In this video, we will dive into the working of supertest. Happy, API easy, or also libraries that do the same as supertest. SuperAgent is an HTTP client. The library of supertest is very similar to SuperAgent. So let us first install supertest as a dev dependency. In one of our previous videos, we had an API where we post a message and the API transforms it to an uppercase string. Now, how can we test this? Let me show this to you. First of all, we will change this path to upper. This will make it easier to test and also easier to show the potential of supertest. Then at the end of this file we need to expose our app variable so we can later on use it in our test. So module exports equals app. Next thing that we need to do is create a spec. Now we start with a very simple test. In this test we see that there must be a slash character at the end in the URL. And that needs to be true. Now we can just test this with Jasmine. Great, we have 3 specs that are running and we have 0 failures. In our API, /upper/ is a get and a post method. So we need to test this. So first of all, we need to assign container to a request of our app. Request is supertest and our app is express. Then in our test itself we can use container and we can perform a get with our URL and then we can see with .expect that it allows a get and also that it allows a post. And we expect a status code of 200 and we pass the callback done to this. The most important thing here is that request has a reference to our express instance. It needs that to verify our expectations. When we all test this, you will see that it's all green. That's great, right? We also print out server listening on localhost 8080. Now let us test the post method that brings the sentence to uppercase. You will see that we post to /upper/ set me in upper and that we expect a 200 status code with the same sentence in uppercase. So how will we do that? Well, first of all, we'll do the same as before. Container equals request and then our app instance of Express. And then we will use container .post and then our URL /upper/. We will set me in upper, and we expect status code 200, set me in upper. The set me in upper is our result of our API. And of course, we need to provide done, our callback. Because this test is asynchronous, we have here a done variable that tells Jasmine that our test is done. Now we can just run our test again. We have 5 specs, 0 failures. You see that all our scores are green. That's great, right? Now we have code that's been tested, and our APIs are being tested about their outcome. In this video we have learned how to test our APIs with the library supertest. This is great to test our Express application. In the next video I will show you some references and I will provide you some great libraries and cornerstones of Node.js that we didn't touch in this course but are great to look at. Hi and welcome to the last video of this section about references. In the previous video we looked at how to test our API with supertest. In this video we're going to take a look at what to do next after this course, what the important reference sites are for Node.js, and we will cover some corner cases of Node.js that are always nice to look at. One of the most important sites when you develop Node.js applications is Node.js.org, and also its documentation website. You find the documentation of the LTS version and the latest version here. The LTS version and then the latest version. So I encourage you to look at it and see what you found interesting. We'll take here the latest version. You will see that we covered already a lot of the Node.js APIs in this course. But there is still some more to discover. The crypto API, for example, an API to do cryptographic functionality in Node. Here we find some info. How to create a hash. Another tip that I would like to give you is keep an eye on npmjs.com. Every day there's another JavaScript library that's giving birth. Probably more than one, but okay. It's important to investigate into the viability of the library. How long does it exist? How many stars does it have? How many issues does it have? Is it on GitHub? So when there is an issue, I can fork it and add a pull request. These measurements are important to take a look at when going for an NPM library. These are also measurements that you can see here. It has 64 releases. The last publish was 10 months ago. This is a collaboration or collaborator list. Total amount of downloads. The open issues on GitHub. The pull requests. These are great measurements to take into account when choosing a library. Okay, let me now show you some libraries and tools that are nice to know of in Node.js. A great tool that I definitely want to show you is Istanbul.js. As a developer, you want to sleep well. That is why it's important to have some reports that cover your back. These are great measurements and metrics for your manager to show to them what the quality of the application is. Keep in mind that you are not writing code in function of this tool. You still need to write tests that test your code and your business logic well. The code coverage report is only great to guide in what code still needs to be tested. Node.js is a great tool to provide these reports to your manager, so keep it that way. If you like to explore and play with electronics, you definitely need to take a look at Johnny 5. It's the robotics IoT platform for Node.js. On the site you find some examples how to start with it. This is a simple Hello World application that will blink a LED. Under the hood, it uses an Arduino. Another great library is benchmark.js. It benchmarks your code in Node.js. With this, you can see how long your code takes when you execute it. Another great tool is PM2 to manage multiple node processes. When there is a crash in your application, PM2 will detect that and he will restart your application, so you don't need to worry about downtime. It has log management and an easy way to monitor your application for your console. You can do that with PM2 Monit. It gives this kind of result. Also, Node.js has an awesome list on GitHub. On this list you find categories, and in these categories awesome libraries that can help you in your Node.js application. Let us take an example. For example, we need a mail component in our application. Well, then we can go to mail. Here we go. And then we find here Node Mailer. Well, npm has a library for this Node Mailer. We found it with the awesome list. That's awesome, right? Use Gitter when you have questions or when you want to discuss something about Node.js. There you will find always a person that can answer your questions or that can help you further. Of course, for your questions about Node.js, you have Stack Overflow for this too. It's also a great source to learn a lot and to see what is being living in the community itself about Node.js. Another great resource is nodeschool.io. It has great tutorials and interactive applications where you can learn more about JavaScript, Node.js, and other libraries in the ecosystem. I will show you Byteweiser, for example. So let us install Byteweiser globally. Great. Now that we have Byteweiser, we can just use it by typing Byteweiser. And then here we have a menu where we can choose from. For example, buffer from string. Then when we want to have more info about buffer from string, we can read here. In Node.js, buffer is a global object that provides a way to work with different kinds of binary data. Most APIs in Node Core, HTTP, Net, FS, will give you buffers and will be able to do their job faster if you give them buffers. Then you have a challenge. We need to write some kind of program. And we need to read the documentation about buffers to see how we can write this program. And then on the website we found our answer, buffer.from test. So we will write a program to do a console log with buffer.from and then our sentence bytewiser. And then in program.js we will write our answer. Now we can type in bytewiser run program.js, and that's our result. And then we can type in bytewiser verify program.js to verify our application. Great, we passed our solution. It's always possible to write it on another way, like for example here, new buffer and a bytewiser, but the solution that we typed in was also correct. Great. Our solution to buffer from string was passed. It's great. In this section we have learned how to test our application by giving you some theory and tools to do this in Node.js. We looked into writing tests with Mocha and Jasmine. We looked at testing our API with Supertest. And at the last video, we give you some tools, sites, libraries that can help you in your journey after this course. I hope you enjoyed it. Thanks a lot by joining me in this course. It was a pleasure to have you here. I would like to thank my family, colleagues, friends that supported me in creating this course.